Nowadays, we live connected to the internet 24 hours a day. Although everything seems to indicate that we are moving towards an increasingly wireless world, our internet connections actually depend on thousands of kilometers of undersea cables that crisscross the oceans of the entire planet. How does this infrastructure work? And how important is it for us to be able to use Google, Facebook, or WhatsApp almost anywhere in the world? Currently, 98% of international internet traffic flows through undersea cables. According to Google data, a vast underwater network of cables crisscrossing the ocean makes it possible to share, search, send and receive information around the world at the speed of light. These cables are made of optical fiber. Teresa Bobbis, Regional Director Southern Europe at DCIX, says, "They are not too thick, but inside there are hundreds of filaments the thickness of a human hair and, of course, they are protected with layers of different materials." Transatlantic cables began to be installed more than 150 years ago for the telegraph network. At the end of the 20th century, the deployment of fiber optics brought about a real revolution in the implementation of this type of cable. Today they connect distant continents along the ocean floor and are all around the globe. In total, there are more than 420 underwater cables around the world totaling about 1.3 million kilometers. Some interactive maps show all the undersea cables that are deployed around the world. One example is the Submarine Cable Map, a website that provides data on when each cable began transmitting data, its length and the companies that own it. Southern Europe alone has connections with 45 underwater cables, 10 of which connect to Spain and 9 to Portugal, with another 6 in the process of being deployed, according to Bobbis. Half of these new cables will also reach the peninsula, as the expert points out. For example, one being installed by Google and called Grace Hopper will connect the United States with the United Kingdom and Spain. Despite the fact that these cables are increasingly using more modern technology and are more resistant, they do occasionally break. Most damage to undersea cables comes from human activities such as fishing and anchoring. According to Telegeography, a telecommunications market research and consultancy company, you might have heard that sharks are known to bite cables, but bites like this haven't accounted for a single cable fault since 2007, the company says. In recent years, various researchers have tried to use these underwater cables to detect and predict earthquakes. But in fact, it is seismic movements themselves that are one of the main enemies of these cables. A major earthquake in 2006 in southwest Taiwan ruptured 8 such cables, affecting several Asian countries. Repairing undersea cables is costly and time-consuming. When they break, a telecommunications operator has to find the location of the failure point, bring the damaged part to the surface and replace it with a new length of cable. Avoiding breakdowns is important for a robust and reliable connection virtually anywhere in the world. These cables are indispensable for transmitting large amounts of data with very low latency. Today, having a reliable, resilient, high-capacity network is more important than ever. Although undersea cables span the oceans, in reality all these connections do not end at the coast. They continue over land to link to data centers, which form the physical space for hosting, or interconnection, which are convergence points for content networks, internet service providers and other companies. In other words, while undersea cables are a fundamental part, they are only one of the links in the internet ecosystem. If you enjoyed this video, then subscribe Tech Trend and support us by like and comments.